Hello, and welcome to this video on natural selection. This is a concept that has appeared in a number of videos so far. Many people would already be aware of this concept through high school or higher level education. Those that have not had those classes can use this video on natural selection as a simple primer. Natural selection is one of the key aspects of Darwin's theory of evolution. It is one of the forces that changes the distribution of genes in the population to suit the environment. In the diluted words of Nietzsche, what does not kill you makes you stronger. Natural selection can be best demonstrated by an isolated population, but this concept is not exclusive to only those groups. However, it is exactly what Darwin saw on the Galapagos Islands. It is the adaptation or changes seen in a species when the environment puts pressure on it. This can be food shortages, heat, lack of water, and more. Darwin was not the first to observe acquired traits in a species. This is known as Lamarckism. The most common example is that of a giraffe. A giraffe has a long neck because its parents had a long neck, with which they could reach the top branches of a tree. Therefore they had ready access to food. Their neck grew longer in the child, and this was then passed on to the next generation, and so on. Obviously, this would lead to a continuous growth of the neck, or at least until the giraffe fell over. It was an inheritable attribute, something that once the parents acquired it, so could the children. Since we do not have giraffes that are falling over, there must be another factor at play that explains the way a species adapts. Later, Blyth identified a form of evolution in his zoology work. He observed speciation and artificial selection. The first is the creation of multiple species from one root stock. Camels and horses are a much more pronounced version of this. Artificial selection is the removing of unwanted specimens from livestock. This reduces the diversity, or allows a breeder to separate examples of certain traits they want to encourage or reiterate. This is a more basic version of Darwin's theory, something that Darwin recognizes in his Origin of Species. Most everyone has a vague grasp of how Darwin's finches work. The Galapagos Islands are full of them. Each of the islands has a range of finch species. These have differing beaks, bodies, and habits. They are able to survive on something the other species do not have access or the ability to live from. These differing traits were selected for by an environmental pressure. On the Galapagos Islands, these finches were running out of food due to population growth. There were a variety of alternative foods, such as bugs, seeds, cacti, and other plant matter. This is why there are at least 15 different species of finch on these islands. These include cacti-specific finches, finches with sharp beaks, and a large variety of ground finches. These birds have a specific mutation in their bone morphogenetic protein 4 gene. This creates a differing bone structure and skeleton for future growth. This alters the beak shape and size. It also has a substantial impact on their vocal pattern. This thereby prevents communication and, in theory, breeding between the different species of finch. Another example of natural selection occurs in the Industrial Revolution of Britain. The peppered moth was a species with two distinct variations. The first is white with black speckles. The second is dark brown to black in color. As the Industrial Revolution gained momentum, the local environment around industrial cities became polluted. The speckled moths survived on the white trees around these parts better when the trees were clean. As the trees became covered in soot, the darker moths became able to better survive. They could hide against the dark trunks and not be eaten by birds. This predation by birds is a good example of an environmental pressure that leads to natural selection of one particular trait over another. This concept can be seen in humans. Those living in hot, dry, and sunny climates have darker skin, and this is caused by melanin. Melanin protects from UV radiation to a degree. Those in cold climates have lighter skin. This is less melanin and lets light through. This activates vitamin D. These are both necessary traits for those environments. It can also occur in other ways. Those who live in high altitudes have a larger lung capacity. This allows them to operate under lower oxygen conditions. Another example again is sickle cell anemia. This provides a degree of resilience to malaria. Those with malaria are less affected if they have the disease. This means those who are sick are likely to live longer than those who are healthy, as they are less affected by malaria. On a macroscopic level, this can be visualized as follows. A simple tree showing the points at which mutations cause a separation of species. This split from the original stock creates a subset of the phylogeny tree. Then each of these either become a dead end or succeed to differentiate into more species again. If the environment changes, if the environment does not change, the species is likely to remain relatively stable, barring random mutation. This would then be survival of the fittest within that environment, rather than natural selection. The effect of this process is to shift the allelic frequency, that is, the number of carriers for certain genes. The most advantageous genes are spread, whereas those that are unsuccessful either mutate or die off. This mutation then undergoes the same process of selection. If it is of benefit, it is retained and spread. If it is not, it simply becomes a dead end and that branch of the tree dies. Thank you for watching this video. Please post any comments, questions, or suggestions you may have below.